1 over, give us the equation, 1 over y squared plus cosine x minus 2y, or 2xy, y prime is equal to y plus sine x, where y of 0 equals 1. So just by looking at it, well, it's kind of hard to tell, but it's an exact. It's first order, linear, non-homogeneous. It's going to be an exact problem. So we're going to subtract this over to this side, and it's going to be 1 over 1 plus y squared plus cosine x minus 2xy, y prime minus y plus sine x equals 0. This part here is the n, and this part is the m. Alright, so now we want to get nx equal to my. So let's find our my. It's going to be negative y squared is going to turn into 2y. Y sine x is going to turn into just sine x. And n x is going to equal 1 over 1 plus y squared is going to be 0. Cosine x is going to be minus sine x, and negative minus 2xy is going to be negative 2y. So nx is equal to my. So that tells us that it is exact. So now that we have that nx equals my, we take the partial derivative with respect to x and set it equal to m. So it's going to be partial of theta over x equals m. So negative y squared plus y sine x, and multiply this side over, d of x, and that cancels, and take the integral of both sides. So I'm just going to put the integral here. This was supposed to be negative, but I brought it out, so it actually is positive. And integrate this side, so theta is equal to negative x y squared plus y cosine x plus g of y. So taking the partial derivative with respect to y on each side of theta over y is equal to negative x. G of y. And this is all going to be primed with respect to y. So that's going to be negative 2xy plus cosine x plus g prime y. And this is n, so we're going to set this equal to n, and n is this part, so I'm going to go ahead and write this is equal to this. So 1 over 1 plus y squared plus cosine x minus xy is equal to negative 2xy plus cosine x plus g prime y. And looking at this, these two are equal, these two are equal, so g prime y equals 1 over 1 plus y squared. So g prime y equal to 1 over 1 plus y squared. So integrating both sides will give us our gy. So integrate both sides and dy. So we get g of y is equal to inverse tangent of y plus c. So put this back into this equation with theta here. So we get negative xy squared plus y cosine x plus tangent negative 1 y plus c. And our initial conditions of y of 0 equals 1. So we can solve for our c. Oh, sorry, this is supposed to be equal c because we'll set it equal to c. So using these initial conditions is negative 0 times 1 squared plus 1 cosine of 0 plus tangent negative 1 of 1 equals c. So 0 plus 1 plus tangent 1, that's pi over 4 equals c. So c equals 1 plus pi over 4, giving us the equation of negative xy squared plus y cosine x plus inverse tangent of y equals 1 plus pi over 4.